Hello, my name is Alex, and in this episode, we'll touch upon GitOps, a portion of RobotOps for your robotics workloads that you will enable end-to-end. So let's talk about the tooling that is required for you to be successful as a robotics developer in developing, training, deploying, monitoring, and handling the full cycle of RobotOps for your robots. So we looked at scalable RobotOps as a closed cycle that incorporates MLOps, DevSecOps, and GitOps. MLOps, we're talking about models and policies. DevSecOps, we're talking about containers with the incorporation of the appropriate stack for software in the loop. And then also GitOps, this is edge workloads relative to inference and execution and operations, also incorporating hardware in the loop. And then obviously we have to collect the data back and submit this back to inform the next iteration, the next improvement of your models as it's required. So previously we used weights and biases to train this model, which is for the dexterous shadow hand. And let's just see what tooling we will need to be a successful robotics developer on your sim host as well as on your edge device, such as Jetson Orin AGX. So we'll be developing containers and we'll be wrapping containers functionality into containers. So it's handy to have Docker, and Docker for Desktop has a GUI that allows you to build containers, test containers in different stacks, software stacks inside, such as, again, some of the containers might be purpose-built. Some of the containers might be more generic. Some will with ROS2 stack inside for all the way for robots. Some of them will be miscellaneous, but this is basically we installed Docker for Desktop, which is kind of a handy tool to have. And this will also obviously install the Docker engine with this, right? So you can run and very quickly experiment, build your containers, view the size of the containers, and just do all of the container work as necessary as you're developing. So this is the procedure for Docker for Desktop. Next, we will use K3s, which is the lightweight Kubernetes distribution for edge devices, which is perfect for running Kubernetes on, let's say, Jetson Orin AGX for your robots, for the inference. So there's a very simple command that allows you to install your K3s Kubernetes cluster on your device. In this case, we're installing on SimHost, which is the Microsoft Studio Laptop 2, Surface Studio Laptop 2, but we will also install on Jetson Orin AGX. Then there's a very nice IDE for Kubernetes, management Kubernetes clusters, which is called Lens. And this will come very handy when you have multiple clusters or that you connect to, or even one cluster, but with a very convenient interface that you can view all of the artifacts and all of the objects, Kubernetes objects in your cluster, review the nodes, review the consumption of your resource, as we will be doing some activities on the sim host. And this is how Lens looks like. So you install this for Ubuntu, and then we brought in this default cluster, which is the K3s cluster. By default, K3s installs its config in a specific location. And at this point, we're looking at the node definition after the import. The way you do the import is you can bring in a configuration and upload this or paste a config. So this is the etc rancher K3s. This is where installation of K3s takes place usually. What we did for convenience, we brought this to our local directory, the user directory, and this is the config. So then we copied the config, generated the config, copied the config contents, and then by clicking on plus and add through pasting, you can bring in your definition of your config into Lens. And then after this, like it shows up as a legitimate online cluster with nodes. And this is a single node cluster, Kubernetes cluster that we have here. And then you can have basically access to the terminal conveniently in here with the kubectl command if needed, or like clicking through and showing all of the different types of like workloads, storage, networking, and other things related. If you prefer more like a CLI style, then there's K9S, which is also available, and this way you can run this in terminal. You can install this via Linux Brew and have it your way if that's your preference. So now let's focus more on the GitOps side of things, and imagine that you have a container and you want to basically organize a deployment, a scalable deployment from the cloud after you've done MLOps and DevSecOps cycles onto the edge. So there's arguably the best Microsoft product for the edge is called Azure Arc, which allows you to establish an extension of your cloud for your edges. So you can see there's a set of, like, you can have Azure Arc enabled server. This is more like it's a secure tunnel for like a secure communication on the server level. Or you can have Azure Arc enabled Kubernetes, which is the connectivity on the Kubernetes cluster level. So in order to install Azure Arc enabled Kubernetes for us, for our SIM host, we'll install Azure CLI, quick command. And then as you, in the Microsoft Azure portal, you can just simply go through a couple of steps. And then this is the main command that installs the connected K8s extension that is required for you. And this will bring up your cluster and make this cluster visible in the cloud as well. So this is the successful execution of that command, which we showed earlier in the terminal. And obviously you need to have permissions for, as described in documentation, to execute all of the onboarding. Once onboarding is done via this command, then your cluster your cluster will appear in a connected state. So this is the Studio Laptop cluster. This is my SIM host. And my SIM host is AMD 64 architecture, and there are some caveats relative to installation of Azure Arc enabled Kubernetes on ARM 64 or ARCH 64, which is the Jetson Orin AGX architecture. And then the most importantly, we have this GitOps configuration, which allows you to set up definitions of your GitOps, definitions of your workloads. And after this, with the Flux extension, which is another Arc, Azure Arc extension that gets installed on your machine, which is in my case, it's a SIM host, all of the reconciliation for GitOps will happen. So the definitions are described for Flux as customization. So this is just a format that is described. For defining my sample workload, and decided to go for this before we go to building containers for robots. Just start very extremely simple with the Hello World container from kind of Docker, and in this case I'm just using the BusyBox. This is my deployment and service and customization file in YAML format in GitHub. And then this is what you can hook up your GitOps onto. So this could be a public GitHub, as in my case, or private GitHub. And then there's a token that you have to provide to connect it properly, but it doesn't matter. And then once, as you creating your GitOps configuration in here, ultimately you have to go through a couple of steps. So the first step, you will you'll define basically configuration name and namespace, which gets created as a part of this onboarding and installation, and then scope, name or namespace or cluster scope, and then the type of the extension is Fluxv2. In the future, you will also be able to, because right now it's more like an enablement and reflection of your reconciliation of your changes will happen immediately. But continuous reconciliation enable. But in the future, you'll be able to suspend and review your modifications before it gets propagated. Project Eclipse Symphony comes to mind in this case for management of at scale management of your IoT workloads, because robotics workloads is kind of like IoT workload with the heavy edge included. So then you specify the source, which is your GitHub, and the branch, and the path, which is the base. And then in here we have this deployment and the service. We specify the instance name for the GitOps configuration, specify the path, specify some interval parameters relative to how fast this will be, the changes from GitHub will be picked up as a part of reconciliation process. So this is only reconciliation. This does not include the scheduling as a part of GitOps. This is Flux, it's a reconciler. In terms of scheduling, we can again discuss separately the scalability of that component of GitOps. And then you create a configuration. And once it's created, then it's also conveniently showing you all of the possible errors that you may encounter, and checks basically this procedure checks for compliance. And if something is not compliant or some errors occurred, we will be able to fix it, and we'll be able to work around this as necessary. So while this is being created, the configuration, let's talk about the compatibility with different architectures, with different platforms and versions. So there's another extension of Azure Arc, which is called Azure IoT Operations. So what's interesting about this is that it also takes advantage of Azure Arc enabled Kubernetes, and it deploys a set of ubiquitous components such as MQTT broker, data flow, which is the connectivity to the cloud for submitting data from edge to the cloud. There's a couple of very interesting, like storage accelerator. There's a connectivity to different types of assets on industry standard protocols. So so what's interesting is that and then you can pour your custom workloads on top of this. So like you get the plumbing, and then you can get some additional workloads such as computer vision or robotics or anything else. So this is compatible with K3s. It's also like basically available as an installation of that extension within certain regions. And then, this is just comparing this to like the Flux, which is yet another Azure Arc extension. Azure IoT Operations is yet another extension. There's plenty more. And then if you look at Azure Arc in terms of supported operating system, so we are on Ubuntu 22 LTS, and it's on SimHost, which is the laptop. And then for Jetson, we also have Jetpack 6.2, which is derivative of Ubuntu 22 LTS. But Jetson is a subset of ARM64 architecture, while laptop is AMD 64 architecture. So then this is describing the Flux extension. So essentially it's a Flux operator wrapped as an Azure Arc extension that gets installed in your Kubernetes cluster. And most importantly, for Azure Arc enabled Kubernetes cluster extensions, they're not supported on ARM64 based clusters, with exception of Flux, which works for us perfectly because this is what we're going to do for Jetson or in AGX. But then Azure IoT Operations being an extension of Azure Arc enabled Kubernetes as well, this will only be available on ARM64 platform if you're interested in installing this currently, because of core components for AIO, Azure IoT Operations require AMD 64 architecture, not ARM 64 architecture. It's not compatible with ARM or ARch64 architecture, which is what Jetson Orion AGX is. So we look at the deployment of GitOps now, and it says non-compliant, so we can review what happened to that. And before we do this, like we can see that the Flux extension got installed, so we could see this in the list of extensions. All right, so if we want to see the reason for non-compliance, we can look up the error. And it basically, like what we want to do, we want to switch from namespace scope into cluster scope to just avoid some of the additional configurations. And this is what we're going to do next, just to get going. But this is a very convenient way of catching your errors in case you encounter some of them during the GitOps configuration setup. All right, now we reconfigured our GitOps configuration into the cluster scope and recreated this. And as you can see, we have the compliant configuration. We also explicitly specified namespace that we're going to use for a deployment object and the service in GitHub for Kubernetes objects. And then now if you see the compliance, it's fully compliant. And we can also see that the propagation took place. So in the messages, the latest message, it says applied revision successfully. So that means that if we go into Lens, and if we look at in our namespace, which got created, if we look at for robotics ready namespace, if we look at deployments, and if we look at pods, we will see that everything is running, everything has been propagated and up and running on your edge in your Kubernetes cluster. So this is how you do this on SimHost. We're going to do the same on Jetson Orion AGX. And we will continue the RobotOps series soon. Thank you.